Fusion energy, as we today on the globe knows it, is the attempt to efficiently fuse hydrogen to helium, thereby producing massive amounts of heat, which will then generate electricity. Now, the idea is to fuse hydrogen atoms to produce helium atoms. Now, hydrogen has isotopes, and isotopes are elements with a fixed amount of protons and electrons, but varying amounts of neutrons. So, hydrogen deuterium has one proton and one neutron and one electron. Tritium has one proton and two neutrons and one electron. Now helium-2 has isotopes, and I just saw that helium-6 is radioactive and poisonous. Is it radioactive and poisonous, or just poisonous? Helium-6. Now, producing the helium you want may be more beneficial, or not more beneficial, more easily attained if you use a processes that occur naturally at some point in the history of things. Namely, when did helium-6 form and how does it form? How does tritium form and how does deuterium form? Now you want to produce helium gas, inert, doing fusion. Now did such a study uncover what were the best candidates and the best energy steps to do that? Now, there are things called isomers, and I think isomers are organic compounds that have different chemical distribution of the bonds from each other. I didn't look at that. Now we know that hydrogen gas burns and produces a lot of heat, and we know that water has hydrogen and oxygen molecules combined to form liquid water. We know that less than 2 volts of electricity through water will produce hydrogen and oxygen at each electrode. We also know that the ocean has static pressure in excess of 50 atmosphere, 500 meters down. Now that 50 atmosphere can pump water up to the surface through a vacuum, through a vacuum pipe, through a turbine that produces electricity, which in turn splits the seawater into hydrogen and oxygen. That is very cheap. You don't have to worry about how expensive the electricity is because it's right there, always there, because of the nature of things.